Hey, good afternoon, everybody. Welcome. How's Star Trek going so far? Good? All right. How was lunch? Acceptable? Okay. All right. A little bit of echo in here. It shouldn't be too bad. I'll try and deal with it. And if you're watching in the overflow rooms, you probably don't notice it at all, so great. Welcome, everyone. My name is Steve Smith. This is probably my 7th or 8th Star Trek that I'm talking at. I appreciate you coming to the very exciting title that I came up with for this talk about improving data access, which I know is not at all the sexiest thing that we could be talking about in terms of development here. I could have spiced it up with some AI or something at least, but I appreciate that you've come for something that I think is pretty pragmatic, and I'll do my best not to put you to sleep. So. If you are looking for me online after this, like I said, my name is Steve Smith, but there's about 1 million of us in the world. There's even a Facebook group called the Brotherhood of Steve Smiths that's all Steve Smiths. So I go by R. Dallas online, and so if you search for that, spelled like it is right here, you'll find me or my blog or my GitHub or things like that. The samples for this, I'll have a link to them at the end of the talk. They're also on my GitHub at github.com/rdallas. So go look for them there if you're interested in any of the code that I'm going to show today. So today we're going to talk about data access mostly because it's something that I deal with a lot. I've been a .NET developer since before .NET 1 shipped, and so there's been this evolution of data access technologies from Microsoft as well as third-party implementations, and so there's any number of different ways that you can connect to data. And a lot of that data is structured data. So traditionally, this was what everybody thought of when you said, hey, we need some data for our application. It was like, all right, well, it's going to be in SQL Server or maybe Oracle or something. It's going to be a relational database with tables and columns and foreign keys, and it might look something like this. But these days, it might not be. It might also be document data, and it could be in MongoDB or Cosmos DB or something else. And the way that we access it, we'll use different libraries, obviously, based on where the data is ultimately being held. And so that impacts some of the decisions we might make about how we do data access. It's not unusual even today, and it was way more common 20 years ago for developers to say, hey, I don't need to worry about the database ever changing. That's not something we're ever going to do. Quick show of hands, anybody in here, have you ever had to change the database or database technology you were using on an application you were working on? Like, probably about half. So, I mean, it is not something you always have to do with every application, certainly. But there are plenty of places where it makes sense to be able to have some flexibility around that data access and a lot of advantages you can get if you have some of that. So let's start with the old school, closest to the metal way that you would get data back in the early days of .NET using just ADO.NET. And so the old-fashioned way that folks used to write code to get data from the database was to write something like this. So you'd work directly with ADO.NET, which meant that you would have some type of a collection, perhaps, that you were going to put the data in. All this code that you're looking at is inside of API calls. So I'm leaving out the Chrome for the API endpoint and just showing you the data. But where I'm loading stuff into a DTO, it's because that DTO is going to get sent back over the wire. And so in this ADO.NET world, what you had to do is you had to create a connection, you had to create a command, and then you had to execute that command and return back either a data reader or a data table. And if you were trying to then transform that into some other data structure that you needed, for instance, to return back over an API, then you had some mapping logic that you had to do as well. And so this was the code that you had to write. And if you were writing this code for every call that you ever needed data for, whether it was a read or an update or an insert or a delete, it was fairly verbose, right? That was one of the biggest complaints or biggest issues with working with ADO.NET directly. Now look closely at this code. Do you see anything wrong with it? Anybody have anything that they would say like something's missing or something's not done the right way? Yeah. The connection's not closed and disposed, you said, right? Okay, so that's fair, right? There is no con.close line up here. But because I'm using a using block with the connection, which I think I am in this code, yeah, up there on the second line, that's actually okay because it will clean that one up. But that's one I expect people to look for. Any other ones? Go again, yeah. It's not asynchronous. That's true. This isn't asynchronous. That's not really going to cause any problems with this code, though. I am not using parameterized stored procedures, but I don't need to be for select star from authors, so we'll let that slide for now. I'm not concatenating any strings here, so I'm not going to get you on that one at least. Any others? Those are good points. We're going to hit some of those in the next couple slides. What if the table is huge and I'm getting lots of data? That could certainly be a problem, right? There's no paging here, and this could be millions of rows, or this could be 10 rows. Yeah.
If the author's table were dropped and recreated with columns in a different order, and you're not specifying order above, but you're assuming an order of 0 and 1 below.
Right, I've got some magic numbers in there for the column, so I'm just saying, that ID is going to be whatever's in position 0. So that could be a problem with maintainability if I restructure the table. Sure. Yeah. No. Well, you were closer with your first one, right? So there's no connection.close, which is I expect people to look for, but that one's not actually a problem. There's no reader.close either, but that's actually solved by the same thing. I'm using the using statement on the reader. But the thing most folks may miss, and apparently, folks here either missed it or aren't brave enough to speak up, is that SQL command is also idisposable, right? And I don't have a using block on command on that 4th line there. So, you would expect, some static analysis tool might catch that for you. It's really not that big a deal, typically, if you don't have a using block for command, but it is something that you're supposed to dispose of in that case. All right, now what if you want to do something a little more complicated? That was just a select star from table, which has legitimate issues with things like what if it has too many results, what about paging, etc. But things get even more interesting when you've got a relationship involved. You want to bring back maybe a many-to-many relationship. So in this case, I have essentially 2 constructs. I have authors and I have courses. If any of you have a Pluralsight subscription, think about that data model. Some of the courses, like the one I did with Julie Lerman on domain-driven design, have 2 authors. Very few do, but a few do. And a lot of the courses obviously just have 1 author. And of course, an author can have many courses. I have like 10 or 12 or something. And so in this data model, you have this many-to-many relationship between authors and courses, and creating that join table in order to give you a DTO that simply says, here's this author and their courses, right? Which would be really easy if this were a document database. It's a little bit more complicated because of the fact that we're using a relational store, and so we have to do this more complex query. And ADO.NET doesn't do us any favors there, right? It's a lot of code to put in here, and hence the font is a little smaller for you to see all this. Okay. I don't think I snuck in any problems here. It's even got the using block on the var command. All right, so now let's just talk about how would we evaluate this code compared to other ways we might do data access. Okay, so let's think about some characteristics that we could use as ways to measure, is this code good or is it bad, or what does that even mean? Because everything in how we're going to design this code is going to come down to trade-offs. And so the trade-offs that I'm going to be most interested in here, and what I've chosen to focus on, and there are others, are readability, security, performance, testability, and maintainability. And readability basically has to do with how easily can a developer look at the code and quickly understand what it's doing. And it's often very closely related to how long that code is. So if you can make the code a little bit shorter, but not so short that it's terse and hard to read, then you're going to probably do better on readability, especially if you're trying to combine that data that you're getting with some type of business logic, validation logic, mapping, other responsibilities. So that's readability. Security should be fairly self-explanatory, especially when it comes to data access. There's a few common security problems we want to make sure we avoid. Performance is just how fast is this code going to run. Testability measures how easily you could unit test it, but also integration tests, end-to-end tests, other types of tests for the data access code and the code where it resides, right? Usually your data access code is there because you want that data for some reason, and you're looking to run some business logic with it. And oftentimes that data access logic impacts how easily you can test the business logic. Then finally, maintainability is kind of a blend of some things like readability and testability, but also has to do with separation of concerns or code repetition, if you're following the don't repeat yourself or dry principle. Things like that would impact maintainability. Now, when you look at those stats for pure ADO.NET, I give it this kind of a score, like on a 1 to 5 star rating. Its readability is okay, but if it's a complex query or if there's a lot of mapping involved, it gets pretty verbose pretty quickly. Because it's pretty long and there's a lot of the same stuff you have to do every time. Okay, I always need to open a connection. I got to remember to use a using block, right? That tends to be copy-pasted code. And copy-pasted code is a problem. It creates technical debt because of all the duplicate code that it produces. And it becomes code that you just don't even look at. Right? As a developer, this is the umpteenth function where you've seen 10 lines of code to do ADO.NET. How closely are you really looking for that using statement on the connection this time around when you know it's just been copy-pasted every other time? From a security standpoint, using pure ADO.NET with strings in the code does present some potential problems. The biggest one being the possibility of a SQL injection attack, because we're not automatically going to use parameters for those queries, and instead we might use string interpolation or string concatenation, which could result in a SQL injection attack vulnerability. So I'm only giving it 2 stars for security. Performance, this is about as fast as you're going to get. It's as close to the metal. Anything we do other than this is going to be built on top of it, at least to talk to a SQL database. And so basically all the other approaches we're going to show add to this. There's one thing that we can do that might boost performance a little, and that's to add caching. And we'll talk about that at the end. But that's really separate from how we're getting the data. The testability for this is where it really falls down. It's pretty horrible. Anywhere this code resides, the only way that code can execute is if there is a database it can connect to. If there's not, it's going to blow up, it's going to throw an exception, and you're not going to be able to test that block of code. And because of that, and because of all the verboseness of the code, the maintainability is pretty poor as well. All right, so I'm a big proponent of something I call pain-driven development. And pain-driven development is where you look at the code and you're working on trying to fix a bug or add a feature, extend it in some way, and it's painful, right? It's causing problems to you when you're trying to do the job. You're working on this problem over here, and it's death by 1,000 cuts of all these other things that are problems in the code. So what we want to do is identify what those pain points are, and then figure out a way that we can apply a pattern or use a tool or a library or some way that we can alleviate that pain. And we don't necessarily want to try and fix everything all up front. It's okay if we try and build something and get some actual functionality going before we examine it and identify where the pain points are, and then try and correct them once we've identified them. All right, so with that in mind, let's talk about doing the same thing but with a small change. We're going to use stored procedures. Stored procedures were super common 20 years ago. They're less common now, but they're still perfectly valid to use. I use stored procedures in certain scenarios where they make sense. The big benefit you got from stored procedures back in the day when everybody wrote code with pure ADO.NET was security. The other thing that you got if you weren't the .NET developer that was writing the code, but instead you were the DBA, was you got to keep control, right? You get to keep control over the database, and you knew exactly what queries were running on that database. And so the code doesn't look very different when you say, hey, we're going to use stored procedures. The only thing that changes is your actual magic string of SQL is now the name of the stored procedure you're calling, and you specify a command type of stored procedure instead of just the regular query. When you do this, you also can pass in parameters, which I don't think is on this one, or even this one for that matter. But the only way that you could add parameters to your query is by adding them with parameters. You can't concatenate them into the name of the stored proc and have it actually work. So without spending too much more time on this, because it's basically the same otherwise, what this does is it gives us basically 2 more stars on security. We've eliminated the potential for a SQL injection attack, which by itself is huge, and it's made it so that the code is still very fast, somewhat more maintainable. The actual queries aren't all scattered throughout your code base. They are just inside stored procedures. Whether or not you like that better or not often has to do with your position on who should control the code or who owns the database. But it does give you, essentially these characteristics for working with that code. All right. Now, our big problem still, even looking at this code here, is that it's so long, right? I mean, this is like 20 lines of code just to go fetch some data. And if you had other intentions of things you wanted to do in this method, right, it's now been completely overblown by this extra 20 lines of code just to get the data you needed. And so it would be nice if we could shrink that down somewhat. And so we can use a tool like Dapper, the original Dapper, not the new lowercase DAPR Dapper that's trying to steal the name. And Dapper is a micro-ORM from the folks that brought you Stack Overflow that will make this much, much easier. And it's just implemented as extension methods. And so here, by using Dapper, we can actually fit all the code from those first 2 examples on one slide because of how compact it is. And not only does it manage the execution of the SQL for you, but it will also do the mapping as well. And so if you tell Dapper that I want to get this data and I want you to give it back to me in this DTO that has these properties, it will do all of that for you, and it does it in a very compact manner. They're just extension methods on SQL connections, so they're pretty easy to add. There is still a lot of magic strings inside this code. So in my IDE, magic strings show up as red, and so when you're looking at this and you see all the kind of maroon red color there, that's all the strings that are just inside the code base. So we still have a lot of that SQL logic just baked into the code. There's a maintainability issue with that, because if I refactor my code, if I rename an entity or a property name, or if I change the data schema, either way, separate from one another, none of this updates automatically. Right? None of my refactoring tools are automatically going to update those SQL scripts that are baked into my C# code. And so I'll have to make sure I catch those. And if I don't, then I'm not going to know about it till runtime. There's going to be a runtime error because of that. All right, so if we look at this then, and then think about what the change would be with store procedures, it's pretty trivial, right? It's literally just changing the line to be the name of the stored proc, and telling it what kind of connection it is, just like with ADO.NET. So looking at the score for this, the smaller footprint makes it much more readable. Right? You're not using up nearly as much real estate inside your code just to do the mapping and do all the logic. You still have the query, but you can't really get away from that if we're at the low level where we're specifying the SQL that we actually want to execute, which is the level of abstraction where Dapper lives. From a security profile, it's certainly better. We mentioned that. Performance is excellent. Dapper is one of the most performant, if not the most performant ORMs out there. Entity Framework Core is within a percentage point of just executing raw SQL. That's not normally what you use Entity Framework Core for, but if you were, it's about as fast as Dapper. So there's not really a big performance difference there if you're just trying to run queries. Whatever code there is, though, is still going to make this difficult to test. Right? You still can't run that code without a database being involved. And because of that, that makes it so the maintainability is still not great. It's a little bit better, but it's not as good as it could be. All right. Now, the other thing we haven't really talked about yet is updates. So I've just been talking about queries. We've seen select star. We've seen select with a join. What about if you want to update a record, something changed? And so one of the bigger pain points with these SQL-based approaches is when you need to do an update, you've got a method that looks like this. You've got to put the SQL in there to say, hey, update this, and set this or that column to whatever the new value is. Now, what happens if the table has a lot of properties, or a lot of columns, or the entity has a lot of properties, and you only updated one of them? You have a few choices, right? You could have a custom way to build your update statement that knows which column changed and only update that one. That would be the most efficient way to do it. And it would also make sure that you don't accidentally blow away other columns with old data, because maybe you fetched the record, then someone else fetched the record and they updated the first column and you update the second column. But because you said update all the columns, even the first column that you didn't change, you now revert back to what it was when you read the record, right? So that type of collision takes place if you're not careful, and you can avoid that with different patterns and using timestamps or row stamps and things. But it is an issue to consider, especially when you're doing updates. If you don't decide to just update everything, then you have to write a lot more complex logic to be able to determine which thing changed. Or in your API, you got that? Okay. Or in your API, you've got to make sure that the number of ways that you update things is granular. Right? So instead of just having one update method, you might have an update name method, an update phone method, an update address method, right? Which makes the API for the developer a lot more difficult to work with. It can also have performance impacts if every one of those actually makes a SQL call. So, when the user goes to, save their record and they save 10 different things, you would like that to be one SQL call, not 10 individual update statements to the database. Okay, so that's a pain point with these approaches that we haven't talked about yet, is how we do updates. So we'll look at that in a minute. When we say, hey, the thing that we really need to make that efficient is some type of change tracking. Right? If I knew which columns had changed, then it would be really easy for me to construct an update statement and only update those columns. And that would be the most efficient, and it would have the least likelihood of collisions. And so if we do that, now we're up to the point where we could use a real ORM tool, not just a Micro-ORM. And an ORM is an object relational mapper. And it can track, when we fetch the object from the database, which things have actually changed since it's been pulled back into memory in our application. And then when we tell it, hey, go ahead and update this back to the database with the changes, it knows which ones changed. It constructs an update statement on the fly and only updates the ones that it needs to. Entity Framework Core is the de facto standard ORM that ships in the box with .NET. And so let's see how that. So if we're going to use EF4, simple queries are pretty trivial, right? So we're going to use a DB context. The DB context is the standard way you operate within EF4. And for us to just get select star from author, maybe even just project it or map it into our node. Yeah, hang on one sec. Everybody here can hear, right? Did we turn the speakers down in here? No? No? All right. So in the back, can you hear me all right? Give me a thumbs up. Cool. All right. So where were we? Talking about Entity Framework, make queries. Select star is pretty easy, right? You just do a .to list on a DB context. If you want to do a join, you want to include different things. Entity Framework has ways to do that. Feel good when there's a static. So you can say .include and make sure that you fetch related properties. Otherwise, Entity Framework won't load those by default. If you want, you can implement lazy loading. If you're building a web application, you should avoid lazy loading like the plague, because it's just going to slow down your application tremendously. You have to make lots and lots of queries within one request. My recommendation for the web application is that you want to make as few database calls as you can within that one request. The ideal number of database calls is 0, because it doesn't need any data or because you've already got it in a cache. The second best is 1. But if you use lazy loading, you're going to end up making oftentimes n plus 1 database calls. Far from right. All right, so in here you can see we're also doing a .select mapping. Mapping and data access are often closely related, but they are separate concerns. So in some of these demos I'm showing you, I'll show the mapping. Pretty much in all of them, I'll show the mapping, but the mapping isn't always the purpose of the data access abstraction we're using. Sometimes it can be more efficient if the mapping is tied into the data access technology. And in this case, that would be true because in this second example where I'm making this call and I've got a .select statement right there that's converting this into my DTO. Let's say the author table had 100 columns on it. When I generate the select statement, when EF Core generates the select statement for me, the only columns it's going to have on that select are the ones that I'm telling it I need right here on this select query. It's not going to do select star. It's not going to grab every one of the columns on there. And if I change that select query and I say, well, actually I need this one and that one, right, it'll generate the appropriate query on the fly to just give me the data I need instead of the entire width of the database table. All right, what about updates? Updates are a lot easier now with Entity Framework. This is one of the main reasons why you would use Entity Framework, is because you want that entity tracking capability and the ability for you to do updates where you don't have to think about which columns change. And so if I do change a column, I can just post it back to my API or use a put, use the proper REST verb. And the code inside that API endpoint might look like this, where it's going to go and fetch the record that it wants to change. It's going to then modify that record with whatever I told it is the new value, and then it's going to save changes. And there's a couple things to look at here. One of them is that I'm making 2 database calls now, whereas before, if I just had an update statement, I could just fire off the update statement, right? Somebody comes in with a put to my API and says, hey, change the name from Smith to Jones. I can just say, great, update, name Smith, make it Jones for ID number 123. I don't have to do a select, right? So this has twice as many database calls. But it does also have the benefit of being able to do checks if I want to verify something like a row stamp or something. I'm not doing that here, but I could easily have done that where the API, in addition to sending me the name and the ID, it also tells me the row stamp of the entity when it last fetched it. Because again, this could be coming from a mobile app or a single page application. It could have been an hour ago that they got this record. And if they come in and say, hey, save this change, they might want to know that the record that they're trying to save has been updated in the meantime. And I could send back an error and say there's a conflict. You're trying to update Smith to Jones, but somebody else already updated it to something else. All of that is possible with this approach where you query it first and then do the update. All right, so let's look at our report card for Entity Framework just from this basis. All right, the readability is I think much easier. Looking at this code, or here this code with these two approaches, there's not a lot of magic strings, right? So I don't have the issue where there's all that SQL in here. If you're a SQL person, you might think the SQL version is easier to read, and that's fine. But the benefit of this is that it's pretty much all C#. There's no magic strings, which means if I refactor something, it's going to get picked up by my refactoring tool. If I rename, name to full name or last name or whatever, I don't have to do anything to change any raw SQL. It automatically gets done for me. The other thing that's nice about this is it's a little bit less verbose. The mapping logic is still taking up some space, but I'm getting benefit from that in the terms of the query that actually executes, which I think is a worthwhile benefit. And so overall, I think the readability is good. Security is about the same. I don't have to worry about actually creating parameters and making sure I remember to do a parameterized query like I did with the SQL approaches. Entity Framework just does that all for me. There's no chance I'm going to have a SQL injection attack while I'm using Entity Framework in this manner. There are ways to run pure SQL with Entity Framework, and they would still have some risk, but this approach does not. Performance-wise, it's not as fast, right? There's some overhead to doing that entity tracking. You can alleviate that when you're doing read-only queries and say, dot as no tracking, and that will improve it a bit. But just raw performance-wise, it's going to be faster to drop down to ADO.NET. However, 99% of the time, the performance of your database query is going to come down to how fast your database is, not how quick the C# code is around it. Unless you're in some very tight loop scenario. So the tiny bit of a millisecond or two of overhead I might get here is probably going to be dwarfed by the time it takes me to hop over the network to the data store, run the query, and get the data all back. But it is a hit, so we're gonna ding the performance a bit. Testability, it's a little bit better. I still have Entity Framework, which is tightly coupled to an implementation. I can configure Entity Framework to use a different data source. I can say, I want to just use an in-memory store. I'm going to seed it with a bunch of data, and I'll just use that for my tests. And a lot of folks do that. And I do that with a lot of my integration tests and some unit tests, and it works fine. So it's better. It's not as good as it could be because I can't swap out Entity Framework easily. So if I want to do something else entirely, I'm still locked in and tightly coupled to that implementation. But it is better, and the maintainability is pretty good as well. All right, so now we've been talking about this for, I don't know, almost half an hour, and I gave you a talk with a title that said abstractions in data access, and so far we haven't talked about any abstractions. Right? Everything we've talked about is implementation details and low-level libraries and how to actually do the implementation of writing the code. So at this point, with the pain points that we have, the biggest one being around testability, a little bit with maintainability, we should be thinking about, well, how can we add some abstractions to this? And what might those look like? All right, so let's do that. Let's add an abstraction. And so the abstraction that I'm going to start with is called a repository. And the repository abstraction is probably familiar to most of you, at least heard of it. And that's just because that's the data access pattern name that you use for a service that is used to go and hide the details of how you get data from you inside your application. Now, a repository, if you're following the pattern, is all about the abstraction. It's all about the interface that you're using, that your code depends on, that you own, right? You own the interface, and you can change it, you can manipulate it, you can structure it however you want. In fact, we're going to look at a few different ways that we could create that interface. But if you're not using an interface that you own, you're not using the repository pattern, right? It's great that you might use Entity Framework to plug in and act as the under-the-scenes way of implementing a repository. But you can't just use EF directly and say, oh, we're using repository because EF is a repository. Like, no. The repository is all about that abstraction. And if you don't have that, then you're not really using the pattern. Okay. So let's talk about that abstraction. Abstractions in C# are usually just interfaces. Sometimes they could be abstract base classes. And so a really simple repository that does the CRUD operations we need on a particular entity might look like this. And so, like I said, I've got a web API. There's a controller that I haven't shown you, but it's got the basic CRUD operations of get by ID, list, add, update, delete, right? And so looking at this, you can kind of see that those are the different options that are supported here. There is one additional custom query on here that might jump out at you as being not a basic CRUD operation, and that's the one where we say get with the courses. And I realized as I was looking at this that that there's an async in the middle of that thing, and it really ought to be at the end. But it's getting the author with all of their courses. And I have to make that a separate call because I don't necessarily want to always bring back all their courses. If somebody wants to dispatch the author and that's all they care about because they just want to display their name or something, right? I shouldn't have to go get all their courses. That could be hundreds of records that I'm just going to throw away. And so I want that flexibility. And if you're just using the basic repository interface, you create a method for every different query you might need. You're going to have these types of custom queries for each type of object that you're going to have. Now, it's not unusual to use inheritance or generics, and we'll look at a little bit of that in a few minutes, to make it so you don't have to write a custom one of these classes or interfaces for every single entity you might have. But even in that case, if you're following this pattern, you're almost always going to end up with a custom IAuthor repository that might inherit from the general generic base repository type, just in order to add methods like this one, right? Because you can't have those custom methods be on your general use generic base type that you might use. All right, so when you're working with the repository, you're going to inject that into whatever the class is, your controller, your service, and then call methods on it. And so instead of working with a DB context directly, you just work with the repository. It has methods like list or list async or get me the authors with their courses, and you call those methods just like you did with the DB context for the most part. If you want to fetch the data, this is what the implementation looks like. We've basically just taken the entity framework code in this case and put it inside of the implementation of the repository. Didn't have to write a lot of new code. Right? If I already had the entity framework approach, it's pretty trivial to take that code and move it into another service, call it a repository, and move on with your life. When you do this, the two big benefits that we get are that we're going to have more modularity. We're going to be able to have a data access strategy that you can plug in and swap out with other things. Now, I know we already talked about my production database never changes. I've been working at this company for 20 years, and we've always used SQL Server, and that's fine. But it's not just about your production database. Right? This modularity also has to do with where you're hosting the application. Different types of environments allow you to benefit from being able to plug in different type of data stores. So whether you're running it in a local dev environment, or you've got a shared dev environment, or a shared test or stage environment, maybe you've got a load testing environment you want to run it in, maybe you want to run it in Docker containers sometimes, but not always. Any one of those environments could benefit from the ability for you to swap in a different style of data access, either entirely or by having some decorators or other things you want to use with it. And so this modularity really lets you level up your DevOps game to where you can have different compositions of the application running in whichever environments you might be deploying to, even if they're not for production purposes. The other big benefit we get is testability. So with this modularity, it becomes really easy for us to swap in different implementations. We can create fake data stores. We can create mock data stores. And so our unit tests or our integration tests become much, much easier to write by virtue of the fact that we have this interface. This interface provides us with a seam that we can use to kind of break two pieces of code apart. And so in a method where we're going and fetching data and doing other work, right now we have this seam where we can say, well, I don't really care what the data is that I fetched, or I only want to know how this works if the data I fetched gives me back no rows, right? What will the code do then? And instead of having to set up a database and give it no rows and all this work, when you have the interface, you can just pass in whatever data you want, mock it out or fake it out, and then test that code and see what it would do in that scenario. Much more difficult to do with low-level direct connections to the database, either directly or through entity framework. All right, so let's go back to that pain-driven development. What is still painful about this? The biggest thing that is painful when you are working at this level of this abstraction, this tightly coupled abstraction that's only working for one entity, is that you need to have an interface for every entity. And I have clients that have code bases like this, and when they started out, it was great because they were only doing it for a few things. They were adding tests. The code was getting better. But fast forward a year or two, and now you look in their code, and it's got a folder with like 50 interfaces in it for every different entity they might have, and all the implementations go with it, right? Every single implementation is also a separate class, right? And so if you have n entities, now you have n interfaces and n implementations. That becomes a lot of code that you've got to maintain. A lot of duplicate code in many cases because it looks more or less the same. If you looked at two of them in squints, it's like, okay, that's the same code. The only thing different is the type. The other problem here, and this is a violation of the open-close principle from Solid, is that any of that custom query logic still requires us to add a new method for every one. So as much as we might like to say, well, we'll just get rid of all the variation, we'll just create one generic super repository to rule them all, and then we can go about our day, we'll give it the standard methods it needs. As long as you need to have these custom methods where you can say, well, give me the authors with their courses. Well, give me all the authors from Ohio. give me all the authors that were active in the last 60 days, right? As soon as you have all these different queries that your business needs, you need to have those extra methods. You have to put them somewhere, so you end up putting them on another iAuthor repository or iCourse repository or whatever it might be. All right, so if we look at this report card for the simple scenario of the sort of naive repository approach, it's nice because it's more readable. It's not tightly coupled to the underlying database technology. I'm showing it here using Entity Framework Core in the backend, but you could use Dapper, you could use stored procedures, you could use whatever you want. That's the whole point. There's an interface involved, so you're not stuck with a particular approach. The testability is now greatly improved, right? You can do anything now around the code because you've got that scene, and that's probably the biggest benefit that you've got. Maintainability is still not that much better, mostly because of all those code files that we're going to have to write and maintain. All right, so there is a solution to this, and it is called IQueryable. We can just evolve our repository into a master race of super repositories that have this IQueryable capability. And if we, instead of returning back a list of entities, we just return back an IQueryable of entities, then we'll be able to do anything we want in our code. Any of you have implementations like that where you're pulling back IQueryable from everything? A couple of hands, not too many. That's probably good. Cool. And this is one of the guys from the movie you're going to see tonight. All right, so let's talk about iQueryable. So it's a much simpler interface. Right? I only showed you one custom query, but imagine that there's a dozen different ways to get authors with this, that, and the other. Right? We collapse all those down. We just have one iQueryable of author that returns a list. Right? And so now our repository has gotten much simpler. It would not be a difficult step to go from here to a generic repository. I'm not going to show you that yet. But because of the fact that we no longer need custom queries for every custom thing we might do with this or that entity, it simplifies that dramatically. The way iQueryable works, if you're not familiar with it, is instead of just returning you back a collection or an IEnumerable of the thing, right, like an array or a list, you got back 10 authors, here they are. Here's your 10 authors. They're in memory. You've got them. You can now do whatever you want with them. With iQueryable, you get back an expression of func of t comma bool, where t is your entity. And that's exactly the type that you use if you use link and you have a where statement, is an expression of func of that entity comma boolean. And you can manipulate that queryable from there, right? So when you have some code somewhere that returns back an iQueryable author, and it gives it back to you in a service, right? And now that service got called by a controller. So, inside the service, after you got the code back from the repository, you say, oh, well, give me back those authors, where, the author is from Ohio. Okay, great. And then that comes back into your controller, and your controller can say, well, also, let's just make sure it's only the authors that are active, right? Let's add that too. And then maybe you're using MVC with views, right? Not an API. So now in your view, in your Razor code, you can say, well, actually too, let's just give me back the authors that have at least one course, right? And you add that on there. Now, when you actually execute that query, then that page gets rendered. It's going to construct the where statement based on all those things put together, right? So you're only going to get authors from Ohio that are active, that have at least one course, whatever I said, which is great, right? Because you can make that query finer and more discrete, so that at runtime you're only getting the minimal amount of data that you need. That's probably a good thing, right? When Microsoft talked about iQueryable, that was the demos they showed. Was, hey, look, you don't have to get back all the authors and then whittle it down in memory. You could just selectively filter it down throughout your code. And so with this, the logic moves after the call to the repository, right? And it doesn't even have to be in the same block of code, right? In this case, you're seeing it all in one place, but it can be scattered around in many different places in your application. And that is really the problem, right? It lets us apply filters, includes projections anywhere. And the problem is that with iQueryable, now you can do this anywhere and everywhere. And so the problem is that you end up with these link expressions literally littering your code base everywhere inside of it. So just because you can put data access logic, which that link expression, that where clause, that is data access logic. Just because you can put that anywhere in your code base doesn't mean you should. And it just eliminates all of your data access encapsulation. So just like my favorite Guardian of the Galaxy says, with great power comes great responsibility. So, be careful about how you're doing that. Don't just expose iQueryable and basically eliminate all the encapsulation that you might have. Another Guardian of another galaxy once said, once you start down this dark path of exposing iQueryable, forever will it dominate your code's destiny and it will consume you. So, just kind of think twice before you decide that you want to return iQueryable from your application. All right, so looking at the report card for this, right? We still have good readability, except that the code might be in a bunch of different places. Security hasn't really changed. Performance hasn't really changed. Testability is still pretty good. We still have that abstraction that we can use. It is a little harder to fake data coming back that has to be IQueryable. Not a lot, but slightly more. You can't just return a list. And then maintainability is the part where we kind of take a hit because of the fact that it's so easy for you to move all that data access logic now anywhere in the app. So that's why I would tend to consider implementing your repository abstraction with IQueryable like that to be in more of an anti-pattern than a best practice. And you can agree or disagree. Like this is kind of the grade that I'm giving. Okay, so we can still get most of the benefits of using IQueryable by just switching things around. Instead of saying I'm going to return back something, and then anywhere after that some other thing can tack onto it and make the query more specific. What if we just said, well, we can make this big specific query, we'll just pass it in when we make the call, right? And so that's what using an expression looks like. It's very similar, right? The type is literally the same. It's still an expression of func of t comma bool that you're passing in as a predicate. But now we can pass that into the list method, and we still get back a disconnected type, right? We still get back an array or a list or an IQueryable of stuff that we know is in memory. That's the other problem with returning back IQueryable is that Entity Framework is going to try and translate that query that you use, assuming you're using Entity Framework on the back end, and your code can compile even when it's code that Entity Framework doesn't know what to do with. Right, so if you have some custom function you wrote for how to filter out customers that fit a certain criteria, and you tack that on, where customer fits this criteria, when you go to run that, even though it builds just fine, it can blow up and say, oh, Entity Framework didn't know how to do anything with that function. If you use this approach, you have to make sure that the predicate you pass into the repository is something that Entity Framework can deal with. But anything you do after that, you're only working on an in-memory list, and so nothing's going to blow up at runtime. Right? You have this distinction where all the data access logic and connections to the database happen inside the repository. And once it gets back out of the repository, it's just in memory. It makes it much easier to reason about your code. All right, so when you call the revised interface, it just looks something like this. You just pass in the expression. In this case, the expression is the second line there that I'm passing in. That is of type expression of func of author comma bool, and that's what's going to make it do that filtering. All right, so we now have more encapsulation, right? We've got it so our database is not having its data logic go everywhere. But we still have some pain, right? We still have way too many interfaces and implementations. There's still a lot of link logic that's inside the code. Sometimes that link logic can be pretty complicated, and a lot of times it gets copy-pasted around inside our code base. So looking at this, we've improved things a little bit, right? The readability is a little better. Maintainability is, okay. We don't have the data everywhere, so it went from a 2 to a 3, so it's a little bit better. Let's talk about a new pattern that we can introduce that makes this even better. So the pattern that I really like to use in this case is something called specification. And specifications are a design pattern which is used to encapsulate query logic as a class. And so using this pattern, you have these really small, basically value object classes. They're generally immutable. You pass in whatever things they might need, like parameters or things like that, in their constructor. And then once you have a constructed specification, you can pass that into your repository, and it can use that to construct a query. So it's pretty simple. One of the big benefits you get from it is that it is a well-named class. So if you remember, those of you that are old enough to have worked with stored procedures, or if you're still working with stored procedures, one of the big benefits of stored procedures is that there's this library of known good queries that you can use. And so if you're trying to go find a way to go list the active authors or whatever, instead of you trying to figure it out and remember, well, how did we do that? Was that if they bought something in the last 30 days, or if they were is active was true, or what was the rule, right? If you've got some stored procedure that says list active authors, you're pretty sure that's the right one. You just plug it in and go. Same thing with specification, right? You can have a class called active authors specification. And again, if that's the thing you need, you just use that specification. It's there on the shelf for you to grab. The things that you can put into a specification are basically all the things you might want to do with your data access, including, obviously filtering, but also what data to include, projection, like we saw, where you can say a .select and project it to a different type. You can add paging, you can add support for caching, anything like that you can put into the specification. So our revised interface, if we're going to use specifications instead of a custom predicate or instead of returning IQueryable, becomes something where we just pass in this specification type instead. All right, and so then our implementation code is going to look something like this, where inside of the specification, this is what the actual repository code looks like, right? So it has a DB context inside the repository. When you pass in a specification to this get method, it goes and uses IQueryable inside the repository method. That's perfectly okay, right? The problem is when you expose IQueryable outside of the repository. Inside, you can use that to filter things down progressively using a specification and get back just the result you need. In this case, it'll have any includes that were provided, it'll have whatever predicate, and it'll give you back that data. So now your usage looks like this. And the main thing to look at is just these top 2 lines, right? Every time you need to go fetch data from the database, if you're using a specification, the first line of code is going to be go new up the correct specification and pass it in whatever values it might need, you know, an ID or a string or whatever filters and things like that it might have, and then call the repository and pass the specification to it. The benefit of this is that now you get this well-named, easy to test, easy to find, C# code way of expressing what your query is. You can unit test those expressions directly. Don't even have to have a database. You can unit test them just with a list or an array and verify that they give you back the filtered down code that you expect. And it's much, much easier for you to write this code. Now the mapping code is still here, mainly because, like I said, it's a separate concern. But if you really want to, you can actually pull the mapping logic into your specification as well. We'll see that in a sec. So what still hurts? Well, in this case, we've gotten rid of all the link expression stuff from our calling code. Right? All the link code is now encapsulated inside of the specification, and you're not going to be copy-pasting link expressions all over your code base anymore. Every time you have a new way you want to query stuff, you put it into a well-named specification. You put it in the specifications folder. If you're using domain-driven design, that lives with your aggregate for whatever aggregate it applies to. So the author aggregate or the customer aggregate is going to have a subfolder of specifications for how to fetch it. You put that there in your domain model, so it's not part of your user interface logic or your business or your infrastructure logic. I mean, it's just part of your domain model or your business layer. All right, so looking at a report card here, you know, our testability is much improved. We can unit test the actual queries themselves now as specifications. Now you're going to want to run integration tests too, because obviously how Entity Framework interprets that thing in a real database might be very different from how it works on an array. But it's not bad to have both. Readability is nice, as you've got well-named names for these things. The problem with link expressions is they don't usually have a name associated with them. You could assign them to a variable and then use the variable, but almost nobody does. Usually you just type .where and then spew out a bunch of link stuff, right? And so having a name for what that code actually means turns out to be really useful for the maintainability of the application, in addition to the readability. All right, so now is a good time for us to talk about generics. So we've got this problem where we still have an interface per entity, we still have a repository implementation per entity, but they look really similar. So we can take one interface that is going to have all of the operations we need and use that as our generic specification and our generic repository. And between those two generic things, we'll be able to do all the data access we need. So this is just a subset shown here of repository methods. So in this case, there's a single that takes a specification. There's a list that takes a specification. And you can imagine there's also an add and an update and a delete, etc. But by having just these things on our generic specification, repository, we no longer have to have a different interface, different types for every different entity. That also means that if we have a service that's working with a couple of different entities, we don't have to pass in separate types for every single one of the things it might be. Well, in this case, you'd still have to pass in an I repository of author and an I repository of course, but we don't have different, actual concrete types of I author repository or I course repository. So this interface of I repository of T is something that you own, and you can add some additional generic constraints to it. So this one's very basic. This is just one for a demo, where it's just saying the type can be any class, whatever class you give me. You want to give me a I repository of string? Okay, fine, that should work. That's not really going to work, by the way. But you can constrain that down and say, well, if you have a base entity class or an I entity interface that all of your entities use, you can say, well, where T is an I entity or a base entity or whatever. And now your repository is going to give you, some type checking to make sure it only works with entities. Even better than that is if you're using the aggregate design pattern in DDD, what the aggregate design pattern does is it says, hey, when you've got a master detail collection of things, instead of letting the developer just manipulate the detail rows, one by one, however they want, insert one or change one, right? That parent record really needs to know about the state of the whole thing, so it doesn't get out of state, out of whack. And so with the aggregate design pattern, you say, the master record is the aggregate. And then you can put something on your repository to say, it only works with types that implement an interface called iAggregate root. And it'll make it so your repositories simply don't work on any of your entities that aren't aggregate roots. It gives you some type safety on the compiler, making sure that developers aren't accidentally doing the wrong thing. All right, so a sample specification might look like this. This is just one that says, give me an author with their courses. And you can see it just has the where statement to fetch the correct author with their ID, a couple of include statements to make sure it grabs the related columns. In this case, it can also build up the cache key. If you're using caching, one of the biggest problems with caching is getting the right key for the data so that when you fetch it, you're always getting back the appropriate data. If your key isn't specific enough, like if I didn't have the ID as part of this key and I just cached it as, author with courses, then the first request comes in and it says, give me all of Steve's courses, and it would cache that. And then someone else would come in and say, okay, now give me all of Julie's courses, and it would show them Steve's courses, right? Because the cache key didn't include the author ID. We don't want that, especially not on like your bank account. And so making sure that your caching includes all of the different parameters on the query is very important. And what better place to do it than inside of this class that is the query and has all the parameters. It makes it really easy for you to do that. All right, so then your usage of this with generics looks pretty much like it did before, whether it was the non-generic or the generic version. You see we create the specification, we call the repository, and then we do all this mapping logic with the DTO after that. If we want to add mapping, we can do that. There's just a variant on the generic specification where you say, not only am I going to specify the type that this operates on, right, the author type, but I'm also going to specify the type that I give you back, right? So there's two types involved. I want to have you go and fetch things that are based on authors, but I want you to give me back an author with courses DTO. And so all this code here, including all the mapping, is actually inside of the specification now. And so when you call the repository, instead of it giving you back just the set of authors, it can give you back the actual DTO that you want. Don't always recommend this. I do think mapping and data access are usually separate concerns. But this gives you all the benefits of running that projection through Entity Framework so that Entity Framework can only hit the columns that it needs for that projection. So it does have performance benefits and other benefits, including making it so that the code that's calling it is much simpler, right? Because now that controller code, that endpoint code that's actually doing all the work that we've been talking about this whole time, now is just 2 lines of code here, right? And it's even simpler than it was when we were using Dapper, which was very simple itself, right? So we've moved all the query logic into a specification. All the mapping logic is also in the specification. And the repository just goes and implements that code that's baked into that specification. So if we look at the grade for this, right, I think it's very readable to look at that code, right? I'm not lost in the weeds of the plumbing of whether or not I use the using statement on the connection. I don't have to look at SQL. I don't have to worry about the SQL getting out of sync with my data model or my business domain model. The security hasn't really changed. Once we move to Entity Framework, we're still using Entity Framework here. You could write repositories that use SQL string concatenation and had SQL injection attacks. Don't do that. But here we're not doing that, so the security is about the same. Performance is about the same too. It's not going to be as fast as just writing SQL directly to the database, but it's very testable and it's very maintainable. And I've been using it for a few years now with good results. If you add a cached repository on top of this, then your performance becomes excellent too. In fact, with any of these data access approaches, if you put some caching in front of it for data that is suitable for being cached, you're going to have 100 times faster code just because you're not making that trip to the database. And it's really, really easy once you have an interface to use the decorator pattern to add caching repository or caching decorator rather to that repository to make it easier to apply that. In fact, with a single generic cache decorator, you could go to any one of your specifications, like this one you see here at the very last line, where it's enabling the cache. And inside of that decorator, that one decorator class you'd have for your entire application, it would look at that and say, is this enabled for caching? Yes, okay, then I'm going to use the cache. Otherwise, don't cache it, right? And so now you can control the cacheability of every query in your application at specification level, and you never have to write any of that caching code more than in that one place, right? So your code becomes extremely maintainable and far less buggy because there's not different ways of doing caching in 100 different places in your code. All right, so if we summarize the whole thing, and we look at all those star things, and stars don't fit well in a grid like this, I would say it looks something like this. And unless I made a typo putting this up here, you can kind of see where the different numbers lie in terms of how readable, how secure, how fast, how testable, how maintainable these different patterns are in my experience. Now, it's not to say that I always use the cached repository one at the bottom, which has one of the higher scores. If I have queries that absolutely need to have the highest performance, there's no problem whatsoever with dropping down and using Dapper or using straight ADO.NET even if you want to. But by and large, if you're just doing CRUD operations in a business application, using the techniques that I've just shown on the the later end of this spectrum, except for IQueryable, are going to be a good approach for you. And so hopefully you found this useful. There's different approaches here. They have different trade-offs. We didn't always just add stars as we went. Sometimes we fell back a little bit. The low-level code, generally, you're going to want to encapsulate. You're going to make sure that database logic isn't scattered throughout your whole application. Complex query logic should also be encapsulated. You don't want to have huge blocks of magic strings of SQL, and you don't want to have huge blocks of link statements that don't have a name and don't have anything associating with them what they actually are doing. You want to be able to say what they are, and using a specification, you can name those things. The calling code should be simple and readable, and if it's doing other stuff in addition to fetching data, the data access code shouldn't dwarf the real work that's being done in that method. And so you want to try and come up with a way that you can make those data access calls, a line or two if you can. Leverage the right patterns that make sense for your application and your trade-offs. Combine patterns together so that you can have repository plus specification plus decorators to give you a huge amount of gains inside the application, unlock a lot of scaling. You do that plus generics, and it makes it so all of your data access code is in like 3 files in your application plus the specifications, and that's it. Right? You don't have hundreds of interfaces or hundreds of repository implementation or hundreds of places where you have linked code. Right? You just have specifications, 1 DB context, 1 generic repository, and that's it. All right. So with that, thank you very much. I hope you enjoyed this talk. Let me know if you're on Twitter. You can find me as @rdallas. I appreciate any feedback. If you need mentoring, hit me up at NimblePros. Slides are here, or sorry, not slides. The code is here on my GitHub. It's called .NET Data Access Tour. It's updated to .NET 7. Hope you enjoy the rest of Stir Trek. So that's all I got. Thanks. I do have time for any questions for 3 minutes or so. Yes, sir. How does the performance change if I were to introduce iasync enumerable? It would just be another method on the repository interface if we're talking about using repository. I haven't used iasync enumerable that much. The biggest benefit you get from it is, as I understand it, is the memory, because you're not buffering it inside the thing. You're just taking it and streaming it. And there's no reason why you couldn't have an interface on the repository to do that. You could have a list async that returns an IEnumerable or a list. You could have a separate list async that is an async enumerable, right? And then just call the appropriate one, and it should just work the way you would expect. So the performance benefits would be whatever the performance benefits you're getting from using async enumerable, you would have. Any other questions? Great. Thanks, everybody.